Hello all, I am Vasanth, Azure Associate Administrator. This project done by me. Find the linked link in the description box. And this video is about the complete Docker workshop. We already know that Docker is one of the best containerization open source platform. So here I'm going to do a hands-on training session on Docker workshop, exercises, demos, and guided projects. Here we have a total 9 parts. It covers core concepts like building images, running containers, creating multiple Docker compose containers application, and the basics idea of a Swarm orchestration, like example like Kubernetes. So Docker workshop exists to bridge the gap between the theory and the practice in containerization. It also helps for certification for Docker associate preparation, boosting resumes in Devops or cloud roles, and many more. Okay, without getting delay, let's get started. I'm deploying Linux VM from Azure portal. I create a research group as DevOps1, and the virtual machine name I keep as VM1. Region I select Central India. Here I use SSH public key. I use a public IP address. I download the key. I already installed Git Bash. I will be using Git Bash. I set an inbound role to allow all ports. VM is successfully connected. Now I install application packages. apt update. I am installing Docker. So Git is already installed, so no need to install Git. So let us start from part 1. Now I copy the GitHub repository path for cloning with GitHub. I will install the application tree, which helps to see the files and folders all at once. So I'll see what are the files are inside. This is an to-do application. So they used the to-do application for this getting started app. Okay, I create a new Docker file. Docker file is not there. So I'll create a Docker file. In this Docker file only image will be created. Here we use Node.js image and exposed to the port 3000. You can see 3000 port. Now I build this image and run the container as instructed in the document. So building an Docker image is the process of creating a portal layered snapshot of your application and its environment from a Docker file. So this image can be used to run containers consistently anywhere. It's one of the Docker's core workflows often done during a CI/CD pipelines. So I'll go step by step as guided instructions by the document. Now I'll run the image by using this command. So container will be created. Now I will check the website. Yes, it's working fine. The website is working fine. Now we'll move to next part. In this part, we are going to edit in source code. I change the content in the source code, which will be replicated as same in website type. So the content, the code will be stored in this path only. So I change some content in the source code. I change the text. Just for editing, I give some text. It will get changed only after the container is deployed. Like I remove the container. Again, I run the container. So I'm running the container again. You can see it is not changed. We have to rebuild the image also. So I'm going to remove the image. First, I will remove the container. Stop the container. Remove the container. Now I remove the image. And again I rebuild the image. Now you can see it has been changed. Okay, next step is we are going to share this application file to the Docker Hub, where Docker Hub centrally manages this file. Now I'm going to send in my to a Docker Hub repository. So Docker Hub, the public registry, hosts over 1 lakh official images and billions of pulls annually. Fun trivia like the most popular image is Nginx, pulled more than any other image, powering 30% of the web. I create a repository repo2. I'm using Docker login. If I want to log in with Docker, I use this URL to connect my device with Docker, and I copy and paste the password also. So my device will be connected successfully. So before pushing, I use tag command. I will add a tag. I created repo2 as a repository, so I use the repo2. Now I use the docker push command. Now what the application file we have, it will be pushed to the Docker Hub. You can see the file is uploaded successfully in repo2. Now to pull the image, I use the play with the Docker terminal as shown in the document. If I want to share the file to any, the person can pull from the Docker Hub. So to pull the image, I use this play with the Docker terminal. Oh, now I try to pull the image. Docker pull. Docker pull s 303 / repo2. You can see the pull is complete. The you can see that Docker image is also same. The Docker image is also same as in the main file c8f c8f. Okay, next step is I check once this container is also same. Your container is not available. Okay, next step is persist the volume. Persist the DB. See, the Docker volumes were inspired by Unix file systems mount points, but a fun twist is the early volumes could leak data if not named, so leading to a creation of anonymous volumes that Docker auto cleans, saving developers from storage nightmares. So I create volumes with the name to do DB. This command for removing all the containers. This volume command creates the new container also. Now I will input some messages or text here in the to do application. I just use some funny messages. Now we'll inspect the volume. I use this command to inspect the volume. I copy the path of the volume. Now I go to the location. Not this. We have to go for to do DB. This one. Actually, a single Docker container can bundle an entire app ecosystem into a lightweight package under 100 MB. So compared to gigabytes for a full VM, revolutioning cloud efficiency. So you can see that messages are stored in this volume database. Yes, hello all. All good. So next step is we bind the container to the file. So we bind the container to the file which we have. We use bind modes. I'll use copy this command. So I use this command which is in the current directory. It should be in current directory only. Over 50% of Docker setups in enterprises are orchestrated with the tools like Kubernetes or Swarm. But surprisingly, many still run solo containers or simple microservices without full orchestration. The Docker's open source nature exploded its adoption from 0 to 1 million users in under 2 years. By 2014 and 2015, it's integral to 70% of a Fortune 500 companies' cloud strategies despite early uh, skepticism as just hype. Here again, we are going to edit in source code. So before binding, make sure a container is available. Now I am going to change the content in the source code, which will be replicated the same in the website as well. So I change the content in the source code. So same it is will be replicated in website also. So you can see that without stopping or reviewing the container, we can update this application. Before it was not like that. You have to stop the container, remove the container, and rebuild the image. But we can update automatically. Okay, next step is multiple container application. Now we'll add the MySQL database. So we'll create a network. Now we'll add the MySQL databases. So the multiple containers data will be stored in the MySQL database. Each MySQL container gets its own network namespace by default, reducing attack surfaces, hackers breaching. One won't touch others, a boon for microservices. Now I will exit. Show the database first. You can see the database is available to do's. Now I exit. This command helps to store the data from multiple containers. The Docker lets you spin up isolated MySQL instances in seconds for development or staging. The swapping version per project for without polluting your local setup. The official MySQL image on Docker Hub is pulled over 100 million times annually. So it's proving to go for everything from hobby blogs to enterprise ERPs. Now I'll type some messages. These messages will be stored in the DB. Mm. Now I execute the DB. I'll enter that containers number. Actually, not this container. You have to give the it's MySQL ID. 1C. Now I execute the DB and provide password. We can see the messages are stored in this DB. You can see the messages are stored in this DB. Hello, hi, how are you? So next step is the Docker Compose. For Docker Compose, already we have done a video. You can check previous video. We have done till here. Now we can create new folder and a new Docker Compose file for new image. So same as this previous video, I create new custom image. Same as the previous video, I create new custom image. For that, first I remove all the containers. Now I'll create a new folder. Here I use a Docker Compose YAML file. YAML dot YML. Uh, Here I use the version 3. Here I use Nginx image latest version. Now I map the current folder to use the HTML file. Any ports can be given. Here I give 80 port. See, in Docker images are layered like an onion. Each instruction in a Docker file adds a read-only layer, enabling efficient caching and reuse, which can speed up builds by up to 90% on repeated runs. For index HTML, I copy code from ChatGPT. So here only we have two files. One is the Docker compose.yaml where image is available. In the index we have code, whatever application we have to run, the code is here. Now I validate the image by using this command docker compose config. Okay, now we'll install Docker compose. Mm. We have to change the volume into volumes. The image is validated successfully. This Docker compose up command helps to build and run the image containers simultaneously. Docker composes uses a YAML to define app stacks and launches them in a detached mode, handling dependencies via depends on. You can see that website is working fine. We can alter heading also. So altering in HD in index.html file creates a content outline. The search engine treat it like a table of contents. So the strategic changes can improve page availability and user navigation. So I'll try to update another index.html forms. So the updating index.html forms which auto-validates the user data, reducing JavaScript bloat, a code tweak that cuts the errors by 50% in validation. So the website is updated successfully. You can see it's working fine. Now what next? So next up we'll try Docker, Dockerswarm. Dockerswarm and Kubernetes are both container orchestration tools designed to manage, scale, and deploy Docker containers across the clusters. The Swarm is Docker's native solution, while Kubernetes is a more robust open source platform. As of 2025, Kubernetes dominates, powering up to 70% of production workloads per CNCF surveys. But Swarm remains viable for lightweight setups. So for setuping Swarm, I want three instances. So I'm going to deploy three instances in Azure portal. I choose the virtual machine scale set VMSS, so I can deploy three instances at a single click. I choose uniform instance count 3, and I use the password as a normal password, username. Networking, I choose public IP also. And allow selected ports to SSH. Next, here in advance, we can see we can run the custom script also. I want to install Docker on three instances. So instead of manually installing the Docker one by one, here I can automatically install the Docker in all the instances at once. So I give script to install Docker package and run some command to create and enable the Docker. In packages, docker.io. Installing package only Docker package. Other than nothing. Review and create. If you are in a Docker-centric environment, need a quick setup for small clusters, or want minimal overload, you can choose Swarm. Or if you want to building a production grade or scalable apps with complex needs, you have to choose the Kubernetes. This Docker Swarm supports up to 1000 nodes and 30,000 containers, manual scaling via Docker service scale. Whereas the Kubernetes handles the 5000 plus nodes automated in horizontal pod auto scaling. So it's based on the CPU or memory matrices. Now I'll allow all the port. This will be applicable for 3 instances. So VM is connected successfully. Now we'll check the Docker version. So Docker is installed successfully. Docker info. You can see the Swarm is inactive. Docker info. Swarm is inactive. Now here we have 4 instances, but I use only 3 for the span. I want to choose a instance for a manager node. So I will use this instance as a manager node, remaining 2 as a worker node. I will install the net tools. So here you can see the uh, node IP address also. In if config, you can see that node IP address. Now we'll create swarm. For swarm document, we have to go for manuals and engine, Docker engine. In the Docker engine, you'll get swarm mode. From swarm mode, you'll get all the information. So to create swarm, the command all will be here only. Just as bees in a swarm, they communicate via phenomena and divided tasks without a central boss. The Docker Swarm enables multiple Docker engines to coordinate automatically, scheduling tasks, balancing loads, and handling the failures through simple join commands. So this reflects swarm intelligence, a concept from biology and AI, where simple rules led to complex, resilient systems. The container orchestration is the process of deploying and maintaining large number of containers and services for the application to run as intended. Benefits of container orchestration is deployment of containers, scaling, resource allocation, load balancing, and health monitoring. It helps developers and IT administrator can deploy and manage cluster of Docker nodes as a single virtual system. So Docker Swarm is a container orchestration tool, part of the Docker engine. You can see this node is not a swarm manager. So we have to initialize swarm. So for that we have to use a Docker Swarm init command. The swarm initialize command is available in the create a swarm section. I give the IP address of this node. So this node will be acting as a node manager. The other nodes will act as a worker node. When we initialize swarm, we will get a join token. When we copy paste this join token to the other node, then they will act as a worker node. Swarm is active. You you can see that managers and nodes are one. Now I paste this token to other host. You can see this node joined a swarm as a worker. I will paste the token here. This node joined a swarm as worker. Sorry, this command not found. I will try it again later. But one node is joined. If you see here, we can see there will be two nodes. Your manager is one and the node is two. One node is missed. I will connect it later. If we lost the token, we can retrieve the token also. So this is the command to retrieve the token. If this token is not there, we cannot join the other host. So we will get the token. Now I'll create a container services with one replica. This is a hello world alpine ping. The first Docker image ever built was a simple hello world container in 2013. But today over 13 million developers worldwide use Docker, making it the best standard for containerization. Now I create a container services with one replica. I use Docker scale service to create 5 containers. You can see here we have 2 containers. On the other node, we'll be having 3 containers. So you can see the containers are distributed equally. I'll join this third node also, third instance node to join Swarm. So I copy this token from manager node and paste it to the worker node. You can see this node joined a swarm as a worker. Now you can see 3 node is available and 1 manager is available. Now I try with 50 containers. Okay, over 50% of a Docker setups in enterprises are orchestrated with tools like Kubernetes or Swarm. But surprisingly, many still run solo containers for simple microservices without full orchestration. You can see what the 50 tasks we have given, 50 containers we given. It is distributed equally. The containers is equally divided in worker node also. In second instance, containers are available. In third instance, also containers are available. There are many containers. Now you can see the 3 node is available. So here you can see the containers are distributed equally in all the 3 nodes. So whatever the task we have given, it will be distributed equally. The 50 node also is distributed equally. So the Docker Swarm also works like Kubernetes, but this Swarm is best for only small clusters and work in Docker only. Whereas the Kubernetes works in all large-scale clusters with multi-cloud. So we go through this document, we'll get more information. Okay, here ends the video. Thank you for watching. Bye.